My name is Vinay Flores. This is my oral presentation for the Fast Track Semester Project assignment on force vectors on inclined plane. I'll be presenting a summary of my paper and explaining each force on the system utilizing my physical model made of wood. I also will be solving the equation for the acceleration of the system and explaining each step. This system is based on Newton's second law of motion, which states that all forces of an object are equal to the mass times the acceleration. In this system, two boxes are connected by a string that passes over a pulley. One is resting on the ramp and is represented as M1 in color green with a mass of 5 kilograms. The second box is hanging from the string and is represented as M2, also in color green, with a mass of 6 kilograms. The ramp has an angle of 30 degrees. The friction in this case will be 0.2, since that's the kinetic friction of wood on wood. There are two axes playing a role. The y-axis that is going up in the same direction as the normal force, and the x-axis which is going along the ramp. In this case, the normal force has no friction in the x-axis. The friction will be along the x-axis. Since M1 is not moving along the y-axis, the normal force and the force of gravity are the same in the y-axis, therefore they can cancel out. The forces acting on this system are gravity acting on the two boxes shown in this diagram as M1G and M2G. Since M1 is resting on the incline, there are two additional components acting on this box, which are M1G cosine of theta, which is perpendicular to the incline, and M1G sine of theta, which is parallel to the incline. These two components then replace M1G, which is no longer needed. Another force acting on M1 is the normal force, which is represented as N equals to 1G cosine of theta. The last force is friction, which is equal to the normal force times the coefficient of friction equals to the M1G cosine of theta times U. In order to solve the problem and find the acceleration, the equation F equals m times a will have to be rearranged to a equals F over m. F refers to the net force and m represents the total mass of the system. Once all the forces are applied, the formula should look like this. This basically means the force caused by the mass of m2 subtract by m1g sine of theta, which opposes the acceleration, minus the friction, which also opposes the acceleration, divided by the sum of the masses. Once all the data is added to the equation, it should look like this. Once this equation is plugged in into the calculator, the result is 2.35 meters per second square. According to the rule of significant figures, since there is only one significant figure from the data obtained above, the results should be around to 2 meters per second square.